Have you ever wondered whether we're truly alone in the universe or if there's something more to our existence than we can see? Imagine a scenario where the James Webb Space Telescope finally reveals that we live inside a black hole. Join us as we explore more about our world and delve into ideas that may challenge everything you thought you understood about the universe. So, what exactly are black holes? They're not just something out of a sci-fi thriller. In fact, they are very real. A black hole is a region in space where an immense amount of matter has been compressed into an incredibly small area. Imagine a star several times more massive than the Sun, all packed into a space the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape. Scientists have been fascinated by black holes for a long time. Initially, they were thought to be objects so dense that they could trap light. The most striking theories about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overpowers everything else, leading to the formation of a black hole. Identifying black holes is no easy task, as they emit no light. However, scientists have developed methods to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it pulls that matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays in the process. Black holes also have a significant impact on their surroundings. They can consume nearby stars, produce strong beams of radiation, and even influence the formation of new stars in some areas while suppressing it in others. How do black holes form? Picture stars, once bright and shining, meeting their fiery end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes can emerge. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into neutron stars, extremely dense objects but not dense enough to trap light. If a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As these massive stars break down, something unusual happens near their surfaces. Time itself begins to behave strangely. From the perspective of someone far away, time appears to slow down near the event horizon, the final defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours. Occasionally, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, it creates an epic and incomprehensible scenario. Scientists have long grappled with understanding the sizes of these cosmic phenomena. Black holes come in two main sizes, large and small. But small is relative. Large black holes, the remnants of giant stars, can be as much as 10 million times the mass of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone, an immense number capable of swallowing anything in their path. And then, there are supermassive black holes, at the outer limits of the size spectrum. These black holes are millions, if not billions, of times more massive than the Sun and are located at the centers of large galaxies, including our own Milky Way. They seem like massive voids, pulling everything around them. The renowned physicist Stephen Hawking spent much of his career discussing black holes. His theories were well established, though some were difficult to confirm due to a lack of advanced technology. But now, hope is on the horizon. Not too far off, a single revolutionary instrument is changing everything. The James Webb Space Telescope, JWST, is here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel and a testament to human ingenuity. Sure, we've launched other space telescopes before and they've done their job well. But this extraordinary machine is on a level that's truly remarkable. The JWST makes the Hubble Space Telescope look like a basic piece in comparison. The retail price of this astronomical wonder is an astounding $1 billion. Yes, you heard that right, a staggering number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with tremendous contributions from over 300 universities. However, we shouldn't forget the risks involved with such a grand project. The JWST is venturing into an unknown world, pushing the limits of what we know, and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made numerous incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sun shield and large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after aligning and calibrating, the telescope is almost ready for full operation. One of the most exciting moments for the JWST was when NASA announced that it had captured its first significant pictures of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light, gathered by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446 in which 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory fine-tunes the individual sections of the primary mirror, it will begin the process of stacking these images to form a single, clear view. Thanks to its sophisticated technology, the JWST will help researchers study the early stages of the universe following the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are very difficult to detect due to how they interact with their host stars. By making powerful observations, the JWST will allow scientists to closely study these planets, analyzing their atmospheres and exploring the conditions necessary for life. Its capabilities can help scientists better predict whether specific planets might be habitable. Beyond focusing on planet formation, scientists will study these exoplanets to understand how matter is structured on a massive scale. This, in turn, will help us understand how the universe has evolved, forming the galaxies we see today with their diverse shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand how they evolved. Researchers are also trying to determine how we got the collection of galaxies we see today and the ongoing processes that lead to the formation and merging of galaxies. Ultimately, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt, and guess what it has found? Compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are found everywhere, from distant galaxies to comets in our own solar system. They're fascinating not only because they could form the building blocks of life, but also because they help scientists track star formation. When bright radiation hits these PAHs, they become excited and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is often a sign that there are hot, energetic stars nearby. But here's the astonishing twist. A bold astrophysicist, Ismael Garcia Bernard from Oxford University, decided to investigate 3 interesting galaxies: NGC 6502, NGC 731, and the Eili Beautiful Stephan Quintet, as well as NGC 749. These galaxies are millions of light years away, deep in the darkness of space. What Garcia Bernard discovered will send shivers down your spine. In the central areas where the black holes reign, he observed an abundance of PAHs. But here's where it gets chilling. The radiation near these massive black holes altered the structure of the PAHs, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into nothingness, consumed by the very darkness. The larger PAHs survived, finding refuge within thin, dense gas clouds. It's as if they found their own protective shelter against the fury of the black hole's pull. Now, you might wonder why this matters. For space scientists who rely on PAHs to track star formation, it's a huge deal. Star-forming regions are often completely saturated with electrically charged PAHs. If those particles are destroyed near black holes, tracking star formation becomes a real challenge. But don't worry, our dedicated space researchers aren't backing down. Garcia Bernard and his team are eager to dig deeper into this dark abyss, wanting to study more galaxies, each with its unique twist, to uncover the secrets of how these remarkable PAHs survive in such extreme environments. They are determined to explain the specific properties of PAHs hiding within the black hole zones of destruction in galaxies. Here's another game-changing discovery from the James Webb Space Telescope. It has detected what might be the oldest black hole in the universe. This colossal monster is an exceptionally large black hole, weighing in at a stunning 10 billion times the mass of the Sun. The JWST managed to detect it by identifying faint glimmers of light dating back to the very beginning of time itself. This eerie, forbidding discovery was made at the center of a young galaxy, just 570 million years after the universe was formed. Cosmologists believe there might be even older black holes hiding in the depths of space. It's fascinating, though unsettling, to think about what other revelations could be lurking out there waiting to be discovered. One thing is certain. The James Webb Space Telescope is providing us with a glimpse into the darkest corners of the universe, and what we're uncovering is nothing short of mind-blowing. The discovery of the oldest black hole known to mankind has sent shockwaves through the scientific community. This massive beast could very well be one of many black holes that existed during the infancy of the first light, a period that began around 100 million years after the Big Bang, when the universe was just a billion years old. Cosmologists are puzzled by the sheer number of these black holes and how they managed to grow to such titanic sizes. However, the researchers who found this latest black hole published their findings on the preprint server AR14, and the paper is yet to be peer-reviewed. Leading researcher Rebecca Larson, an astrophysicist at the University of Texas at Austin, believes there could be many more black holes waiting to be discovered. She expressed that the James Webb Space Telescope is allowing us to explore cosmic history in a way that was previously unimaginable. She is excited to see what else the JWST will reveal, as it is poised to uncover the massive secrets of the universe. Who can say with certainty what other mind-blowing cosmic surprises await us in the vastness of space? The universe is full of privileged experiences just waiting to be unraveled. With each new discovery, we inch closer to unveiling its dark and astounding mysteries. As we dig deeper into the universe, black holes continue to reveal the complex intricacies of our reality. Their formation is not just the result of dying stars. They can also arise from the merging of neutron stars and other massive objects. This cosmic collision leads to remarkable phenomena such as gravitational waves, ripples in space-time detected by observatories like LIGO. These waves provide insights into the violent processes occurring in the universe, including those that create black holes. The search for dark matter also intersects with the hunt for black holes. Dark matter is an elusive substance that makes up a significant portion of the universe's mass, yet it remains elusive to current observational techniques. Some scientists speculate that primordial black holes, which formed soon after the Big Bang, could be responsible for dark matter. If true, this connection could provide a pathway to unlocking one of the universe's most important secrets. But the James Webb Space Telescope isn't limited to studying black holes. It may also observe the atmosphere of exoplanets in perfect detail. By analyzing the light that filters through a planet's atmosphere as it passes in front of its star, researchers can detect chemical signatures indicating the presence of water, methane, and potentially even signs of life. The JWST's infrared capabilities allow it to peer further back in time than ever before, capturing light from the earliest galaxies and stars. This ability is a game-changer for scientists eager to understand galaxy evolution and the conditions that led to the universe we inhabit today. As we continue to push the boundaries of our understanding, the relationship between black holes and the structure of the universe remains a captivating mystery. Every new discovery brings us closer to unraveling the fundamental nature of reality, revealing a universe that is undoubtedly more complex and interconnected than we ever imagined. As we continue to explore the mysteries of the universe, one thing becomes increasingly clear. Our understanding of space, time, and existence is still in its infancy. The The more we observe, the more questions emerge, especially when it comes to the nature of black holes and their role in shaping the cosmos. Recent advancements, particularly through the use of the James Webb Space Telescope, JWST, are shedding new light on phenomena that were once beyond our grasp. One of the most perplexing areas of study is the role black holes may play in the evolution of galaxies. We've long known that supermassive black holes reside at the centers of most galaxies, but scientists are now considering a more active role for these cosmic giants. Some researchers propose that black holes could be crucial to the formation and regulation of galaxies themselves. As black holes consume matter, they could generate powerful jets and radiation that either trigger or suppress star formation in the surrounding galaxy. This means that black holes could influence the very structure of galaxies, shaping them in ways we are only beginning to understand. In addition to their effects on galaxy evolution, black holes may also provide clues about the fundamental nature of physics. The extreme conditions near a black hole could offer insights into quantum mechanics and general relativity, two pillars of modern physics that have yet to be fully reconciled. For instance, the behavior of matter and light near a black hole's event horizon challenges our understanding of spacetime. The way information behaves as it crosses this boundary could help answer some of the most profound questions in physics, including the fate of information that falls into a black hole. Moreover, the search for life beyond Earth is gaining new momentum. The JWST is pushing the boundaries of what we know about exoplanets and the potential for habitability on worlds beyond our solar system. By observing distant planets, scientists are now able to identify atmospheric conditions that could support life, offering hope that Earth is not the only cradle of life in the universe. This quest for life is intertwined with the broader search for understanding how the cosmos came to be, whether through the formation of stars, the collision of galaxies, or the creation of black holes. Every discovery brings us closer to answering the age-old question: are we alone?